Its debut stunned the entire world. To this day, only China, South Korea, Japan, and France can produce it independently. LNG ships are not only powerful tools for ocean transport but also key to national strategic reserves. Their interior is equipped with approximately 60 centimeters of perlite panels, protecting gas that, when cooled to -162 degrees Celsius, compresses to 1/60 th of its original volume, turning into liquid. With 20 centimeters of insulation and 9-story tanks filling 4 compartments, plus dual-fuel engines as tall as 2 floors, these ships can be propelled forward. When fully loaded, their power is equivalent to 60 moving Hiroshima atomic bombs. To fully understand this, we must first explore the history of LNG. The predecessor of LNG ships was the Alamosa-class cargo ship supporting World War II in 1945. After being transferred twice, it was sold to a British company in 1958 and converted into the Methane Pioneer. However, its initial design used 5 tanks, which evolved over time. Nowadays, it has been reduced to 4 tanks. Although the number decreased, the volume has increased several times over. Types can be classified into membrane, spherical, and SPB self-supporting models. Today, we will focus on building the commonly used LNG ship for marine transport. It is more compact in design, optimizing storage space. Here is the local Samsung Heavy Industry shipyard, comparable in scale to the Dalian Shipbuilding Industry Group and Hudong-Zhonghua shipyard. However, in LNG construction, Samsung and Hudong-Zhonghua face fiercer competition. As a shipyard, besides a large amount of steel, there is also a large number of workers. Over 20,000 people work here daily, consuming 3,000 kilograms of fish, tons of rice, and countless fruits and vegetables daily. Let's begin with step 1. First, building steel plates are transported to the appropriate spot. Automated CNC processes cut them precisely. Although manpower is unnecessary, this production line still has 75 employees working in shifts. Each pair of workers manages one device, maximizing the efficiency of laser cutting machines. In just minutes, raw materials are ready. To meet the demands of different shapes, the workshop is equipped with a 30,000-ton integrated rolling machine. When steel plates pass between the upper and lower rollers, the forming machine, with manual presets, rolls them into the required angles. Different hydraulic pressures yield different results, but they can't be used as is. Manual adjustments are needed for secondary corrections. It relies on experience, no advanced with hands slowly making adjustments. Fortunately, there's an assisting tool, reducing mental strain on workers. This is similar to a ruler used by students. When placed on a steel plate, you'll notice the inspection process is fascinating. If the board fits flush, the angle is correct. If there's a gap, it means it wasn't pressed properly. Now, let's watch how this process is completed. 3 employees are assigned to the post. 2 measure while 1 controls the machine. First, place the wooden board on the surface. Move it forward in a gradual manner and observe. Once a gap is found, mark it on the surface. Then adjust its shape using hydraulic pressure. Now, we move to the 3rd step, welding. The red support frames are positioning racks for steel plates. When we raise and insert them into the box, the supports act as jacks. This helps wrap the plates around at precise angles, enhancing welding stability. It prevents slipping and collapse. Here, machine welding is used. One of the few steps where workers can take a breather. The welding gun moves forward automatically. Once one spot is complete, the entire steel plate is formed. Next, we enter the production line with the most workers. This is also the most sought-after high-paying job at the shipyard. Most earn over $10,000 a month. This is manual welding, which machines cannot replace. The work demands are extremely high. If you're outside the ship, the job lasts 7 to 8 hours a day. But under the hull, the situation becomes much tougher. The hull space is less than a meter high, making it hard to move. If you manage to crawl in, you'll find you can't even stand up straight. As a Russian worker once said, "I'd rather go to the battlefield than kneel here every day." The hull space is often less than a meter. Although ventilated, it's still filled with thick smoke and noise. Yet, for thousands, this is just another normal day. Perhaps that's what passion is. With the segmented hull welding complete, it's then transferred to the forward section. A 3D model reveals the hull is made up of individual pieces. From afar, you can barely see its size. But up close, the sheer magnitude of this giant is overwhelming. Workers even use bicycles to navigate the area. The transport trucks have dozens of wheels. Here's something you may not know. An LNG ship is longer than an aircraft carrier. Let's take a comparison. Here's a sailing ship navigating the open seas. Next is a 20th century cargo ship. When an aircraft carrier appears, the others look tiny. If an AMG ship emerges, even the mighty aircraft carrier seems insignificant. If you're unfamiliar with aircraft carriers, here's a vivid comparison. This is a standard-sized city bus. If you line them up bumper to bumper, you'd need over 60 buses to match the length of the ship. Globally speaking, only a handful of countries can build these independently. Japan, Korea, and India are major importers. 3 of them have already gone from 0 to 1. India reportedly has plans on the agenda too. It seems India doesn't want to stay third forever. At this point, the hull structure is complete. Next, we enter the most challenging stage, tank work. Natural gas can only be transported in an environment at -162 degrees Celsius. This involves compressing the gas to 1/600th of its original volume. To achieve this, 2 layers of insulation are installed inside the ship. The panels are typically made of nickel alloy, steel, and multi-layer fiberglass. A 30 cm thick layer of polyurethane foam is added at the base. Both fiberglass and foam have excellent thermal resistance. When we model the ship's interior, it contains 4 sets of 9-story storage tanks. Each group is isolated and does not interconnect. The yellow material serves as the primary and secondary barriers. Next, open the polyurethane foam in the primary barrier. You'll find an additional layer of perlite board inside. When the polyurethane foam is stacked, the insulation board's thickness exceeds 60 centimeters. As long as there's no external collision, the hull model remains undamaged. Now, the insulation boards are being manufactured. First, apply a layer of special adhesive insulator on the surface. Then, in pairs, workers place them inside the hull. Once installed, quality inspection is conducted immediately. Next, an alloy containing 30% nickel is applied to the insulation board. Nickel has a low expansion coefficient, allowing it to maintain consistent size in low-temperature environments. Then comes high-precision welding at the millimeter level. The key is that the total area of these 4 storage tanks equals 4 to 5 football fields. The process involves welding one section at a time after placing it. Thus, building a large ship takes months, if not years. This process is understandably time-consuming. Now, let's take a look at the finished insulation details. Do you know how much natural gas the tanks can hold? They store 40,000 cubic meters compressed to 1/60 th of the original volume. There are 4 such tanks in the ship. The loading method is also highly unique. Let's look at this special loading pipeline. Reportedly, it transports 13,000 cubic meters per hour. To fill the tanks completely, it takes a full day. In fact, the core component of the ship is still the internal combustion engine. Its design and structure are as tall as 2 stories. Looking at the valve cover alone, it's hard to gauge the size. But compared to a person, the scale becomes evident. Importantly, the engine runs on diesel fuel, but can also use natural gas as a power source. In the industry, this is known as a dual-fuel engine. The engine is categorized into low-speed 2-stroke and medium-speed 4-stroke types. It ensures continuous fuel supply during ocean navigation. Now, let's look at the cockpit. The control panel is densely packed with various display screens. This ship is called Gaslog Skagen. It is now cruising steadily in the southern Indian Ocean. LNG ships are classified into LNG only and LNG-LPG dual-purpose ships. They can transport not only natural gas but also gases like ethylene and ammonia. Have you ever wondered why a giant iron ship weighing thousands of tons doesn't sink? It's all thanks to Archimedes. When an object enters a fluid, it experiences an upward buoyant force. This buoyant force equals the weight of the displaced fluid. Although the ship's weight is substantial, its design allows it to displace a large amount of water. This explains why the ship can float on water. Design plays a crucial role in this. We should also thank Archimedes for discovering the principle of buoyancy, which greatly contributed to optimizing hull design in later years.